Okay, this guys is January 2022, paper 2H. So expand this. So guys, we do y times 2, y times minus y, 4 times 2, 4 times minus y. Giving us y times 2, 2y, y times minus y squared. 4 times 2 is plus 8, and 4 times minus y is minus 4y. Then you have to simplify this by adding, I'll put the y squared term first, guys, so it's minus y squared. I have to do the 2y minus 4y is minus 2y, and then plus 8. You can put these in any order, but that's fine. Okay, factorize this. So I factorize the numbers. I'll take out the highest common factor of 15 and 35, which is 5. 5 goes into 15 and 35. I'll then take out b cubed, because I've beat the 5 here and beat the 3 here. So there's 3 common b's, like this is b, 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 and this is b, b, b. There's only 3 that's in both. Similarly, there's only one c that's in both, because there's only one c in this term here. Okay, now this becomes 3, because 3 times 5 gives me 15. This becomes b squared, because I need my b cubed times b squared to give me the b to the 5. And I don't need any c because I have it here. Then this guy will be 7, because 7 times 5 gives me 35. I don't need a b because I have my b cubed here. And I need c to the power of 8, because c times c to the 8 is equal to c to the 9. And that's it, guys. There's nothing else I can do. Okay, question 2. Fractions, definitely, guys, you need to be able to do this. So to divide fractions, you have to, or you at least definitely should, change to an improper fraction. So we do 6 times 4 is 24 plus 3 is 27. So it's 27 fourths. So 6 3/4 is the same as 27 quarters. Divided by, same thing, 7 times 2 plus 4, 14 plus 4 is 18 over 7. And then to divide fractions, we do, if you may be familiar with the keep, we keep the first one the same, we change this to multiply, and we flip the second one to 7 over 18. So it's keep, change, flip. And then what I would do in this case, guys, is I would divide the top by 9. So I divide this by 9. 27 divided by 9 goes 3 times. 18 divided by 9 goes 2 times. So this is actually 3 times 7. Well, let's just write it like this. 3 times 7 over 4 times 2, which is 21 over 8. 8 goes into 21 2 times, remainder 5, which is 2 and the 5/8. Done. You could, guys, if you want, do this times this and this times this with your calculator and then just divide, but this way works well. Okay, that's question 2. Question 3. These triangles are similar. AB is 4, PQ is 12, or Q is 16.5. This is X, this is Y. We're calculate the length of BC. So if they're similar, guys, I want to get a scale factor. So the scale factor is 12 over 4, because this side, I can pick any two kind of corresponding sides. This side is 3 times bigger than this side. So the scale factor is 3, 12 over 4. So to calculate BC, his corresponding side is the 16.5. So if I do 16.5 divided by the scale factor, 16.5 divided by 3, 16.5 divided by 3, I know what this is, it's 5.5. That gives me my answer, that is 5.5. Okay, then it says write down an expression for y in terms of x. Okay, so this is easier than you think, guys, although it looks kind of annoying. Remember, 12 is 3 times bigger than 4. It's the scale factor. 16 is 3 times bigger than 5.5. So y is 3 times bigger than x. So y is equal to 3x, and that's it. It's only worth 1 mark, but fine. Students sometimes get confused when they only give you some letters and no numbers. Okay, question 4. Each side of a regular octagon has a length of 18 millimeters, correct to the nearest 0.5 millimeters. Write down the lower bound of the length of each side of the octagon. Right, guys, I like to draw a straight line. I then put 18 in the middle. It's correct to the nearest 0.5 millimeters. So the next one up is 18.5, and the next one down is 17.5. Now the lower bound, just be careful here, the lower bound is halfway between these two, and the upper bound is halfway between. I think actually here we need to write down the upper bound for the length of each side. So it's just the length of each side. The lower bound, halfway between these two, is 17.75. You can add them together and divide by 2 on your calculator if you want, or you could just see it. It's 0.5, 0.75 is halfway between it. And this would be then 18.25. So once I've drawn that line, I can just put in my answers. Just make sure you get the right one. 17.25 is the lower bound. 18.25 is the upper bound. Okay, that's question 4. Question 5. The scale diagram shows the position on a map of a house. So 1 centimeter represents 200 meters. Okay, so guys, you will need a ruler here, just to be clear, because this is drawn to scale. House C is on a bearing of 110. House C is on a bearing of 110 degrees from A. So C is somewhere. Remember, guys, bearings. We start north and we turn right. So this would be a bearing of. 90 degrees. So 110 degrees would be somewhere down here. So it'd be somewhere on this line. Now what we'll do is we'll draw the line, but we need to, if it's at a distance of 700 meters, then this distance here has to be, and now what you'll do is you'll just draw this line a certain distance. You need to measure this angle with your protractor. Now there's one thing I actually can't do because I don't have a protractor on this, but this has to be 110 degrees. It's going to look something like this. And then if 1 centimeter is 200 meters, then 1 centimeter equals 200 meters. Then 3 centimeters is 3 centimeters is 600 meters, because I'm just going to multiply by 3, and 3.5 centimeters, because I shouldn't say equals because it doesn't equal. Let's put an arrow. 3.5 centimeters represents, I guess is the right way to do it, 3.5 centimeters represents 700 meters, because half a centimeter is 100. Okay, so this distance, and again guys, I don't have a ruler here, but this distance is going to be 3.5 centimeters, and it has to be exact. So we go 1, 2, 3, 3.5, I don't know, something like this. So this, you mark it there and you put in point C. Okay, that's part A. Then it says, write the scale of the map in the form 1 to n. Okay, so the scale of the map is 1 centimeter represents 200 meters. So that means 1 centimeter represents, well, let's do this arrow, 200 meters. So the actual scale, we need to think, well, what's the scale? How many centimeters is this? Well, 1 meter is 100 centimeters. So 200 meters is 200 or 20,000, 200, 100 centimeters. So 1 centimeter here represents 20,000 centimeters in real life. So the scale is 1 to 20,000. Now that's just 200 times 100 is how I got that. Okay, question 6. So a bag contains only these sweets, and this is the probability for each sweets. It says the number of pink sweets to white sweets is 2 to 1. So guys, what I'll do is I'll do pink to white is 2x and x, because that's 2 to 1, and this will help me find the probability for white. It then says there are 28 red sweets in the bag. Work out the number of white sweets in the bag, but we'll do that after. So let's first get x. So I have the probabilities, guys. Well, some in terms of x, but all the probabilities have to add up to 1 because there's no other colors in the bag. So we have to get one of these colors, hence the probability is 1. This is 3x, 2x plus x is 3x. This is 0.55 equals 1. Add those two together. I then subtract this from 1, giving me 0.45. And I then divide by 3, giving me 0.15. Okay, so now I have this is 0.15, and this is 0.35. Sorry, 0.3. This times 2. Okay. He then says there's 28 red sweets. How many white sweets? Okay, so 15 doesn't go into red nicely, or into 35 nicely. So I'll do it this way. You could turn it into fractions. I'll stick with well, a percentage. So 35% is 28, because he says there's 28 red sweets, 28 has 35%, so 35% is 28. So we want to find 15%. So I could just divide by 35 and then multiply by 15, or I could just get 5. Because if 35% is 28, 5% is this divided by 7. This divided by 7 is 4. And then 15% is just 4 times 3, because 3 times 5 is 15. 3 times 4 is 12. So the answer is 12. There's 12 white sweets. Okay, question 7. Lowest common multiple. Okay, the lowest common multiple of these guys, the way I like to do it is Venn diagrams. So I'm going to say 28 is equal to, we can do our prime factor tree. 28 is 7 times 4, which is 2 times 2. 42 is 7 times 6 and 3 times 2, and 63 is 7 times 9 and 3 times 3. Okay, so that gives me 28 equals 7 times 2 times 2. 42 equals 7 times 3 times 2. And 63 equals 7 times 3 times 3. My Venn diagrams, let's try and draw them here. 1, 2, 3. How good are those circles? Okay, so what we do is we'll call this one is 28, this one's 42, and this one's 63. What's common goes in the middle. Now what's common is only a 7, because I'll change the color again, guys. Only a 7 because there's a 7 here, here, and here. Okay, what's common? Let's just look between 28 and 42. So between 28 and 42, there's a 2. So I'm going to put this 2 here. 1 in each. So I'll put it in this common place here. But I only put in 1, remember. Similarly, between 42 and 63, there's a common 3. So I put in a common 3 here. And then in 28, there's another 2 there. And in 63, there's another 3 here on its own. And then the LCM, the lowest common multiple, is equal to, LCM is equal to 2 times 2 times 7 times 3 times 3. You multiply all of these together. The highest common factor, by the way, is just these multiplied together, which is just 7. So it's 2 times 2 times 7 times 3 times 3, which is 252. 252, that's correct. 252. Okay, question 8. We have average house price in England in 2018 and 2019. Work out the percentage increase in the average house price from 2018 to 2019. Okay, the increase is this minus this. 231776 minus 228314. Okay, 231776 minus 228314. 3462. 3462. That's the increase. To get the percentage increase, I need to put this increase, this 3462, over the original, or the 2018 price, 228314, and multiply by 100. And this gives us 3462 over 228314, multiply by 100, 1.516. 1.516. He says 1 decimal place, so it's 1.5. Okay, the average house price in 2019 was 7.7% greater than the average house price. Sorry, 2019 was greater than 2017. Fine. Work out the average house price in 2017. 3 significant figures. Okay, I'm going to call this X. I don't know what it is. So X times, now I'm going to increase whatever this is, it's X. I'm going to increase it by 7.7%. To do that, I multiply by 0.77. I have to put in the 0, otherwise it would be 77%, and it's not, it's 7.7%. So when I increase this, whatever this number is, by 7.7%, I get 231,776, and that means, because I've got a what I would call a simple equation now, I can just divide by this. So 231,776 divided by 1.077 will give me X, which was the average house price for 2017. So let's do that. 231,776 over 1.077, 215,205. What did I say? 215,205. 215,205 and change, 3 significant figures. So that would be 215,000. 215,000, which is correct. Okay, question 2. Frequency table. The mean is 2, work out the value of X. Okay, so this time, usually they say just find the mean, but now they give you the mean and they say find X. So to find the mean, we do number of points times frequency. So let's call it N for number of points times F for frequency. And I'm going to make a new column. So 0 times 13, 0. 1 times 17, 17. 2 times 8, 16. 3 times x is 3x, and 4 times 11 is 44. So these added together, 0 I'll put in the 0, plus 17, plus 16, plus 3x, plus 44, all divided by the total number of people. It's not the common mistake, guys, is people divide by 5 or 4. That's crazy. What we divide by is the total number of people. Now the total is, if we add up all of these, I get, sorry, not these, I'm going to add up all the frequencies. If I add up all the frequency, I get 13 plus 17 is 20. So let's actually, guys, just write, I'll just write the total here. Total is equal to 17 plus 13 is 30, 38, 48, 49. So 49 plus x. So it's 49 plus x. That's when I add up all of these. So I'm dividing by 49 plus x. And this equals to 2, because this is the mean. And they tell us the mean is 2. Okay, so now I just need to solve this equation. How do I do that? Well, let's first add up the numerator. 17 plus 16 is 33. Plus this is 77. Yeah, so it's 77 plus 3x. That's the numerator simplified. And then I'm going to multiply across by this. So it's 2 times 49 plus x. And yes, you got to put in your bracket. Okay, then 77 plus 3x equals 2 times 49 is 98. 2 times x is 2x. And then we are nearly done. Although I think I've made a mistake. What have I done? Oh no, sorry, I haven't. 3x, I'm going to minus the 2x over here. So x is on one side, and 98 minus 77. Subtract the 77, so x is on the left, numbers on the right. 3x minus x, 2x is x. 98 minus 77 is 21. And that's correct. No mistake. Thankfully, that is question 9. Question 10. Simultaneous equations show clear algebraic working. Okay, the easiest thing to do, guys, is I have to get the x's. Either the x is the same or the y is the same. The easiest one to do, I think, is if I just multiply the top by 2, then I'll have 6x and 6x. So this times 2 is 6x plus 10y equals 6.2. You got to multiply them all by 2. This times 2, this times 2, this times 2. Then the second equation will be 6x plus 3y equals 3.75. That stays the same. Okay. I'm going to eliminate the x's. They are the same sign, so I subtract. Same sign, subtract. 6x minus 6x is 0. 10y minus 3y is 7y. And 6.2 minus 3.75. 6.2 minus 3.75 is equal to 2.45. So 7y is 2.45, which means y is 2.45 divided by 7, which is a nice 0.35. So y is 0.35. Now I need to get x. So I'll sub into equation 1, into this equation. I can sub into any equation that I want. Let's do this one. So it's 3x plus 5 times y, which is 0.35, equals 3.1. 3x plus 5 times 0.35, this times 5, is 1.75. This is 1.75 equals 3.1. Subtract the 1.75. 3.1 minus 1.75 which is 1.35, and then x is going to equal 0.45. So x is 0.45, y is 0.35. 0.45, 0.35. Question 11. So we have a 10-sided regular polygon, and we have to show that x equals y, right? This isn't an easy question, guys. First thing to note, it's a regular polygon. So when I see regular polygon, that often tells me to think about the exterior angle. Now the exterior angle, guys, is this angle here. It's that one, or this one, or this one. They are all the same. They're all the exterior angles. So these angles here are all the same, and we can find them quite easily because it's 360. The exterior angle is 360 divided by the number of sides, divided by 10, which is 36. So this angle here is 36. Okay, what we can also do is say 180 minus 36 is 144. And that gives us the interior angle, because the 36 plus the interior angle equals 180, because it's a straight line. So this is 144. But that means this is 144, and this is, and all these interior angles are 144. I won't do them all, but importantly, this one is 144. Okay, next thing to note is, guys, that there's a few different ways you could prove this, but possibly the easiest way is to note that this is a right angle. And it's a right angle because it's a 10-sided shape. These GF and AB are actually parallel. And this is just a rectangle like this. So this is a right angle there. So this here is a right angle. Now, in a show that question, guys, you have to explain what you're doing. So, well, this is self-explanatory, especially on the diagram, but I want to say that angle BAG is equal to 90 degrees there. Okay, now that means that x plus 90 has to equal 144, because x plus the right angle, this orange right angle, equals the green angle, which we know is 144. So x is equal to 54. Okay, great. Now x is 54. I need to show that y, is also 54, because we have to show that it's the same. So how am I going to do that? Well, what I'm actually interested in, guys, is this other angle here, this one. Because if I get this, I can find y the same way I found x, just, well, slightly different. I can just take it from 90 and I get y. So this angle and this angle are the same. These two angles are the same. And I know this angle and this angle are both 144. So let's call this angle theta, which would mean this is theta. You can call it whatever you like. I like theta for angles, guys. So we have 2 theta plus 144 plus 144. Let's just put them both in. 144 plus 144 has to equal, these 4 angles add up to 360, because in a quadrilateral, the 4 angles add up to 360. That is something you need to know. Okay, I'm then going to solve this. 2 theta plus 288 equals 360. 2 theta equals 360 minus 288, which is 72. And theta is therefore 72 divided by 2, which is 36. If theta is 36, then This is my therefore sign. Therefore, y plus theta, which is 36, has to equal 90, because this is a right angle here, my theta plus my y. That means y is 90 minus 36, which is, guess what, 54 degrees. And then I can just say, therefore, x equals y, and it's shown. Okay, not an easy angles and polygons question, but hey ho. Question 12. Work out the value of a cubed. Give your answer in standard form. Okay, so again, guys, this is one of these ones where if you put this into your calculator can't cope with it because the number gets so big. So if a is 6 times 10 to the power of 40, a cubed is this cubed. So it's 6 times 10 to the power of 40 cubed, because this is a. Okay, now I can cube both numbers separately. So I'll do this as 6 cubed times 10 to the power of 40 cubed. Now 10 to the power, well, let's do another step. 10 to the power of 40 cubed, I'm going to just multiply these powers. But anyway, 6 cubed is 6 times 6 times 6. You can do that in your calculator, guys. I actually do know the answer, but let's do it anyway. 6 cubed is 216. So it's 216 times 10 to the power of 120. Now, while this is correct so far, he says give your answer in standard form, and this is not in standard form. So I have to put this as 2.16. So this is 2.16, but I can't just make this smaller, divide by 100. If I divide this by 100, then I have to multiply this by 100 just to keep it the same size. So this times 10 to the power of 20 is the same as 2.16 times 10 to the power of 122, because I'm going to multiply this by 100, or 10 squared. So this times 100, I add the powers. Let me just show you over here what I mean. It's 10 to the power of 120 times 100, which is 10 to the power of 120 times 10 squared, add the powers, it's 10 to the power of 122. So that is my final answer. 2.16 times 10 to the 122. Okay, question 13. The shaded region is bounded by 3 lines. The equation of one of the lines is given. Okay, good. They've given us the more difficult line. That's good. Write down 3 inequalities that define the shaded region. Okay, so one of my lines is, well, this is one of the lines here. That line is x equals -1. Because it's the vertical line, it's on x equals -1. We call it x is equal to -1. This line is my other line. This is another fairly straightforward line. It's just y equals x. Because when x is 1, y is 1. When x is 2, y is 2. When x is 3 or 4, y is 4. So y equals x, or y equals mx plus c. The c is 0 and the m is 1. So we're just left with y equals mx, or sorry, y equals x. The final one is this one here, which they've given to us, which is nice of them. Okay, so we want to write the inequalities that define this region here. So let's start with the pink one. The pink one, x is equal to -1. So x has to be greater or equal to, guys, because it's a full line. It would be a dotted line if it wasn't also equal to. So x is greater or equal to -1. I say greater or equal to because it's to the right of this pink line. So it's greater or equal to that. Okay. The next one is y and x. Now, which side do I put the the inequality? Well, look at it. Here, a nice trick, guys, or actually the way I teach this is you pick a point here, 0, 2, a point that's in the gray area. Pick the easiest point you can, 0, 1 even, 0, 1. Is, in this point, is y greater than x? Well, this point is 0, 1. Is the y bigger than the x? Yes, the y is bigger than the x. So I'm going to say the region I want is where the y is bigger than the x. So I put y is greater than x. And then the last one, which is kind of the hardest one, I have my x plus 2y equals to 8. Now these can be confusing, but again, let's put in our point. If I put in 0, 1, let's just say here I put in 0 for x plus 1 for y, 2 times 1, and sorry guys, I didn't mean to put the equal sign here, so we're going to put an inequality. So 0 plus 2 times 1 and 8. Now which is bigger, the 8 or the 2 times 1, which is 2? Well, it's the 8, so I have to put my sign this way, so I have to put my sign this way. So x plus 2y is less than or equal to 8. So those are my 3 inequalities, and I can put them here. X is greater or equal to 1, y is greater or equal to x, and x plus 2y is less than or equal to 8. Okay. 14. A zip wire is shown as the dashed line AC in the diagram. It's going to be supported by 2 poles, this and this. Okay, fine. The zip wire makes an angle at x with the horizontal. The design of the zip wire requires the angle to be at least 5 degrees. Okay, work out the least possible height. Right, so this sounds like a confusing question, guys, and it kind of is, but what I'm going to do straight away, one of the reasons I do this, guys, is because I've seen these types of shapes before, and if you just draw a line straight across here, you immediately get a triangle, and we can use our trigonometry knowledge with it. And if this is x here, then this is also x, because well, our alternate angles are our z angles. These are parallel lines, so these 2 angles are equal. This is 90 degrees. And this angle, well, this length is 2.6, just from here to here. And this length we don't know, and this is actually the length we need to find. It's, well, we need to find this length and add it to 2.6, because the post is A to B. So let's call this H. Actually, let me just call it Y, guys, because just so as not to confuse you. H would be the height, the full height of the thing. So how are we going to get Y? Well, he says we want the least possible height of this. So we want this angle here, to be as small as possible. So this whole thing where it says we want x to be at least 5 degrees, they've made this question confusing on purpose, but really you just want to let x equals 5 degrees, because you want this angle to be as small as possible, and they say it has to be at least 5. Okay, so let x equals 5. So I'm going to write here, let x equal 5 degrees. So this is now 5 degrees. So I can use SOHCAHTOA, because this, by the way, guys, is 12 meters, because it's the same length as this. So I can say I want my opposite, I have my adjacent. TOA, let's use tan. Tan of 5 degrees is equal to y over 12, opposite over adjacent. Multiply across by the 12, y is equal to 12 tan 5. 12 tan 5, calculator, 12 times tan of 5 degrees is 1.04986. 1.04986. That is y, but the height, AB, is going to equal this 1.04986, this y plus 2.6, plus 2.6. He wants it to 3 significant figures. Let's just do that. Plus 2.6 is 3.64986. 3.64986, and then we round that to 3 significant figures. 3.65. Okay, that's the answer, guys. Question 14. Question 15. DR recorded the distance in kilometers that he cycled each day for 11 days. Here are results. Find the interquartile range. Okay, so guys, we have to order these from smallest to biggest. So I'm going to go 5, 5. Let's do 5, 5, 7, 8. Be very careful, guys, to do this properly. Cross them out as you write them. Okay, then I'll do 10, 12, 13, 14. 10, 12, 13, 14. 10, 12, 13, 14. 16, 21, 23. 16, 21, 23. Okay. Now, what I want is the interquartile range. How do I get the interquartile range? Well, first we'll get the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 numbers, which means the middle one will be the 6th. 1, 2, 3, 4, 5, 6. This is the middle number. This is the median. Median. How do I know it's the middle? Well, there's 1, 2, 3, 4, 5 numbers to the left. 1, 2, 3, 4, 5 numbers to the right. It is in the middle. Okay, then to get the lower quartile, I get the middle of these ones. I look to the left of the median, so don't include 12, just this, and this. What is in the middle? It's the 7, because there's 2 to the left and 2 to the right. Similarly, 16 is in the middle of these 5, so this is Q3. So the interquartile range, or IQR, interquartile range, is 16 minus 7, which is equal to 9. So the interquartile range is 9 kilometers. That's it. Question 16. DEFG, points in a circle. This is the diameter. We have 42. And calculate the size of DFG. So this is what we want here. Let's call it immediately X. Now guys, if that's 42, straight away I'm going to write this is 42. How can I do that? Well, these are angles, angles in the same angles in the same segment. I think that's what the circle theorem is called. But this one and this one are equal. Now, what else can I do? Well, I have a diameter. So diameter tells me that this is 90 degrees because angles in a semicircle add up to 90. And then finally, I know that this plus this plus this, x plus 42, plus 90 has to equal 180 because opposite angles in a cyclic quadrilateral add up to 180. So x plus 132 equals 180. X equals 180 minus 132, which is 48. So x is equal to 48. Now guys, I'm not going to write down all the reasons because I can't be bothered, but note, you would get, if there's 4 marks, you'd probably get 2 marks if you write what I write here. You have to explain why you did each thing. So you have to write this is 40 angle EF. D is 42 because it's equal to DG. E because angles in the same segment. You have to say this is 90 degrees because angles in a semicircle, or angle in a semicircle is 90 degrees. And then you finally have to say these two add up to 180 because opposite angles in a cyclic quadrilateral add up to 180. So you have to give the reasons. Okay, it's 48. Question 17. show that this can be written as this, right? This is one of these rationalizing the denominator questions, guys. So I'm going to multiply above and below by root 3 minus 2, the conjugate of the bottom. So if that's plus, you change it to minus. If that's minus, you change it to plus. And you're just multiplying above and below, so you're not changing anything because you're basically multiplying by 1. Okay, now multiply these out properly. Root 12 times root 3 is root 36, because 12 times 3 is 36, minus 2 root 12, because 2 root 12, all over. Root 3 times root 3 is 3. Root 3 times minus 2 is minus 2 root 3. 2 times root 3 is plus 2 root 3. And 2 times minus 2 is minus 4. Okay. This gives me root 36, guys, is 6. So definitely just write 6. And this is equal to 2 root 12. And this is all over. This is all over 3, oh yeah, sorry, these two cancel, guys, which is why we multiply by the conjugate, and we're left with 3 minus 1, which is minus 1. Now this isn't quite yet in this form, so I just divide by -1, which means I change the sign of both of these. So this becomes minus 6 plus 2 root 12. But finally, that's also not in the form, because he wants root 12, he wants root something, not 2 root something. So I change the 2 into a root 4, because 2 is root 4. And then I can multiply both of these to give me 1 root, and it's just root 48. And that's the answer. Okay, that's question 17. Question 18. Prove that when the sum of the squares of any two consecutive odd numbers, when the sum of squares of any two consecutive odd numbers is divided by 8, the remainder is always 2. Show clear algebraic working. Right, only 3 marks, guys. First, so guys, to make an odd number, we do 2n to make it even, and then plus 1 to make it odd. So I'm going to let 2n plus 1, and a consecutive odd number means the next odd number has to be 2n plus 3, because if I just added 2, I'll get the next even number, and when I add 3, I get the next odd number. So let this and this be 2 consecutive odd numbers. Okay, it says prove when the sum of the squares is divided by 8, the remainder is always 2. Right, so I need to square them. 2n plus 1 times 2n plus 1 is equal to this times this, 4n squared, this times this, plus 2n, this times this, plus 2n, 1 times 1 plus 1, which is 4n squared plus 4n plus 1. 2n plus 3 squared is 2n plus 3 times 2n plus 3. 2n times 2n, 4n squared. 2n times 3 plus 6n. 3 times 2n plus 6n. 3 times 3 plus 9. Okay, add them. 2n plus 1 squared, this is this squared, plus 2n plus 3 squared is equal to this plus this plus this. Sorry guys, I didn't simplify that. 4n squared plus 12n plus 9. Let's move this down a bit. Okay, this plus this is now this plus this. 4n squared plus 4n squared is 8n squared. 4n plus 12n is 16n. And 1 plus 9 is 10. Okay, now I can actually see the answer, guys, because when I divide this by 8, what I'm going to get is, well, this is equal to 8 times n squared plus 16n plus 1 plus 2. Now, let me just explain what I've done there, guys. I've said that if we, actually, maybe let me do it a different way. I'm just going to divide this by 8. So 2n plus 1 squared plus 2n plus 3 squared. So we're dividing by 8 because that's what he says. He says the sum of the sum of the squares of any two consecutive odd numbers, that's this plus this, when we divide it by 8, we're left with this divided by 8 is n squared, because the 8 goes. This divided by 8 is 2n, and this divided by 8 is 1 remainder 2. So it's 1 plus 2 eighths. Hence, therefore, remainder will always be 2, because you can see this is the 2. It's because of the 10 you can't divide by 10 by 8, but when you do divide by 8 you get a remainder 2. So that's it. That's question 18. Question 19. Okay, PTQ is a diameter of a circle. Fine. RTS is a chord of a circle. It gives us these values. Fine. Calculate the radius of the circle. Okay, interesting. So essentially, guys, I'm going to get this side here, which is PT, and then add it to 3, that'll give me the diameter, and then half it, that'll give me the radius. How am I going to get x though? Well, I get x by using the intersecting chord theorem, which tells me that 12 times 4 equals 3 times x. Now 12 times 4 is 48. And if 3x is 48, then x is 48 divided by 3, which is 16. Okay, x is 16, fine. Therefore, diameter, which is PQ, is equal to, the length of PQ, I should say, is equal to 16 plus 3, which is 19. Therefore, the radius is equal to 19 over 2, which is 9.5. So the radius of the circle is 9.5, and that's it, 9.5. Okay, question 20. Okay, we have a histogram about the height of tomato plants. So this is the frequency density. This is these are the class widths. Now it says there are 12 tomato plants for which H is between 75 and 85, right? So between this and this, we have 12. So the area, remember guys, the area gives the frequency. That, if you just remember that, you can figure out histograms. The area is the frequency. Okay, so that means, look, the base here is 10 because it goes from 75 to 85. So that base is 10, and that pink thing, I don't know what it is, but I would like to know, because then I can actually fill in my frequency densities here. So I can find it easily, because I can say that 10 times h, or 10h, is equal to 12, because our area of a rectangle, 10 times h equals 12, and therefore h is 1.2. Now, once I know that h is 1.2, I know that this is, well, this height here is 1.2, which means this is 1, this is 0.5, this is 1.5, and this is 2. So these little bars, they're actually going up in, and I'll just put this one over here, they're going up in 0.05. So 10 is 0.5, which means 1 is 0.05. Another 10 gets me to 1, and then 1.05, 1.1, 1.05, 1.2. So that's why this height here is 1.2. But now I know all the heights because I have the scale. Okay, then it says, one of the tomato plants is selected at random, fine. Find an estimate for the probability that its plant height is greater than 82.5. Right, so let's get the total first. The total is going to be, let's do this one. So 55 to 60 is 5, so that's 5 times 0.6, because this height would be 0.6. 0.6. 5 times 0.6 is equal to 3. So this area here is 3. Now, similarly, this base is 10, so 10 times this height, that's 0.5, 0.6, 0.7, 0.8. So this is 10 times 0.8, which is 8. So this area is 8. Next one, this is 5 times, and this height is 1, easy, 5 times 1 is 5. This is 5. And then this one is going to be 5 times 0.5, 0.6, 0. No, sorry, I did that wrong, guys. This is 0.5, this is 0.4. So it's 5. This would be 5 times 0.4, which is 2. So this guy is 2. Okay. Now he says, find an estimate for the probability that this tomato plant is just one random. So the total, let's do the total first. The total, let's do it in green. The total equals 3 plus 8, 11 plus 5 is 16, 28, 30. The total is 30. Now I want to figure out how many are bigger than 82.5, right? 82.5 is here. So this is 80, this is 81, 82, 82.5 is there, right? It's halfway between two of these boxes, but more importantly, guys, it is a quarter of this 12. So it's 3. So this is 3 because it's a quarter of this total area. Therefore, the probability, let's just do probability that H is greater than 82.5, 82.5 is going to equal 3 plus 2 out of 30, the total. So there's 3 in here, there's 2 there. 3 plus 2 is 5, 5 out of 30, or 1 out of 6. That's the answer. Okay, that's question 20. Question 21. Here we have a graph. Use the graph to find estimates for the solution where this equals 0. Okay, this one's easy, guys, because it equals 0 here. That would be, so these are going up in 0.1, so this would be negative 0.1. So x equals negative, sorry, 0.2, negative 0.2, and x equals 2.2. He says 1 decimal place, so that's fine. Okay, then he says, by drawing a suitable line, okay, these questions are hard, guys, there's 3 marks. By drawing a suitable line on the grid, find estimates for the solutions of this equation, x squared minus x minus 1 equals 0. Sure, you're working clearly. Okay, now I have 2x squared minus 4x minus 1 is equal to, I want to turn this into this. Okay, so let's go, no, actually, sorry, what I'll do, guys, is I want to turn this x squared minus x minus 1 equals 0. This is the equation I'm trying to solve. And I'm looking at this quadratic. So I want to turn this thing into this thing. Now, how can I turn it into that? The first thing I'm going to do is multiply across by 2, because I need this 2x squared here. So I'm going to multiply everything by 2. This is now 2x squared minus 2x minus 2, and I have to multiply the right by 2 as well, but 2 times 0 luckily is 0. Okay, now this is 2x squared minus 2x minus 2, but this is minus 4x minus 2, so I have to subtract 4x. By subtracting 2x. By subtracting 2x, I will get my minus 4x. Now again, guys, I appreciate this is not easy. So 2x minus 2x is minus 4x. But if I'm going to subtract minus 2x from the left, I have to subtract minus 2x from the right. So this is now minus 2x. And finally, this is minus 2, but this is minus 1. So I have to add 1 to get minus 1, which means here I need to add 1. So this becomes 2x squared minus 4x minus 1, because minus 2 plus 1 is minus 1, and this equals minus 2x plus 1. So to solve the equation, where does this equal 0, that is the very same as solving the equation, where does this equal this? And he says, by drawing a suitable straight line. Well, the suitable straight line is that. It's y equals. So I need to draw y equals minus 2x plus 1. Okay, so in this grid, I'm going to draw y equals minus 2x plus 1. Now, guys, how do you draw y equals minus 2x plus 1? Well, one method is certainly, if you're not sure, you can pick any 2 points. Okay, I'll show you both methods. I like to do this because all you need is 2 points to draw the line. I'm going to pick, first easy one is when x is 0, y is 1, and then let's just pick another one when x is, let's do when x is 2, y is 2, minus 2 times 2 is minus 4, plus 1 is minus 3. So now I've got my 2 points, 0, 1, that's here, and 2 minus 3, that's here. So then I just draw the line like this. But make sure, guys, that you continue it, because we need to hit it at both points. So that is the line. This is the line, y equals minus 2x plus 1. Now, if this is confusing, guys, although I would argue if you can do this question, this is the least of your worries, but let's go. Let me show you how to do it with the calculator. Go to table and you type in minus 2x plus 1. Leave g of x. Start wherever you want. I'll start at 0. And then it gives you 0, 1. It gives you the points. There's 0, 1. It gives you 1, minus 1. It gives you 2, minus 3. It gives you 3, minus 5. And it's the same thing. Now note, guys, the scale is different on the x and the y-axis. So when x is in the x direction, one big box is 1, whereas one big box in the y direction is 2. So just be careful. Okay, now I'm still not finished. I then have to get the intersecting point, which is here, and draw a line down to there. Now, does he want it correct to one decimal place? Yes. So I'll go minus 0.6. This is minus 0.6. And then, because I want the x value, similarly here, I will get the intersecting point, go straight up. That's 1.5, 1.6. So my two solutions are negative 0.6 and 1.6. Okay, x equals negative 0.6 and x equals 1.6. Okay, hard question. Question 22. Here's a rectangle. We're given the area is less than 75 centimeters squared. Find a range of possible values. Okay, this is a difficult question, guys, because it's a quadratic inequality, because less than is obviously an inequality. But there's marks to be picked up here, guys, and it's not an impossible question by any stretch of the imagination. So the area is this times this. So we can all get this mark. 2x plus 3 times x minus 1 is less than 75. Area is less than 75. Okay, now we have to multiply this out. 2x times x, 2x squared, 2x times minus 1 minus 2x, 3 times x is 3x, 3 times negative 1 is minus 3, and this is all less than 75. Simplify this, 2x squared plus x minus 3 is less than 75, and then I'm going to bring the 75 over here, or subtract the 75, means minus 78 is less than 0. Okay, so now I have a quadratic. I'll just move this, guys, that's annoying me. Okay, now I have a quadratic inequality, which I need to solve. Now, one thing to note is you can solve this on your calculator, but you have to put in a step. I'll show you in a second. You have to factorize this, or at least use the quadratic formula. But you can get the answer here on your calculator. So if you go to inequalities, degree 2, it's the second one because it's less than 75. It can't be equal to, it says less than. So I press the second one. I put 2, 1, and minus 78, because 2, 1, and minus 78 there. Press enter, and I get the inequality. X is less than, and guys, we need to be very careful here. I'll show you this in a second, but we get x is greater than 13 over 2 and less than 6. Sorry, minus 13 over 2. Now just be super careful here, guys, because we have to look at this. This is a rectangle. If x is smaller than 1, like let's say, for example, x was a half. If x was a half, you'd have a half minus 1, which is minus a half, which means the length of the rectangle would be negative a half. That doesn't make any sense. So x actually has to be bigger than 1. So x has to be bigger than 1. So that kind of supersedes this inequality. So the left part of this inequality has to change to 1, because x has to be bigger than 1 because of this. And now you can't always go use that first. You have to get this first, because maybe, I mean, that could be bigger than, it doesn't necessarily have to be a negative number. That could be 10, which makes this redundant. So you do this first and then look back at this. So x has to be bigger than 1, and then this part stays the same. X has to be less than 6. So that's actually the final answer, this. However, as I said, we have to factorize this or use the quadratic formula to show where these two values come from. But by getting this, guys, this helps us factorizing, because I would have struggled to factorize this because I'm not sure I knew 13 times 6 is 78, which it is. 13 times 6 is 78. So it'll help me get the factors. The factors are going to be 2x. This is how I do this, guys. You can factorize however you want if it works. 2x and x. Factors of 78 are 13 and 6. I'm going to put 13 here and the 6 here because of this, because it's the 13 over 2. So the 13 goes with the 2, the 6 goes with the x, and this is going to be plus and this is going to be minus. Now, the reason for that is because when you multiply it out, you're going to get plus 13x minus 12x to give you this 1. But you can also look at it and think, what is the opposite sign? If this is negative, then the factor is positive. If this is positive, then the factor is negative. So then you just say 2x plus 13 times x minus 6 is less than 0, and that's it. That's full marks. You can then go straight to, you can just put the answer down here. But remember, you have to include the 1. X is less than 1, or sorry, greater than 1 and less than 6. You can write a reason for this, guys, here. You can say as x minus 1 is a length. Okay. Question 23. So we have PQR. PQR is obtuse. Work out the area of triangle PQR, sorry. Give your answer to 3 significant figures. Okay. To get the area, guys, I need an angle, because I need to get I need to use the formula a half AB sine C. That's my area formula. So I can use, this is A, this is B, and this is C. This is my angle. Let's call it theta. So I need to find that angle. Now I can't find this angle yet because I don't have this side. So I can't use the cosine rule because I don't have this side. And I also can't use the sine rule because I don't have this side. So I can't find this angle. But I could find this angle here. Let's call it alpha. Call it whatever you want, guys. I'm just not going to call it x because I'm going to call this well, actually, I don't even need that side. Let's just call it x. This is x. Okay. Now, I'm going to use the sine rule to find x. I'm going to say sine x over 4.2 is equal to sine 18 over 1.6. It's sine of this over opposite side equals sine of this over its opposite side. Then sine of x equals 4.2. I'm going to multiply across. So 4.2 sine 18 over 1.6. And finally, x is the inverse sine of that, right? So I need inverse sine. Sorry, I need to go back here, guys. Sorry, escape on menu 1. Right, I need inverse sine. Shift sine 4.2 times the sine of 18 over 1.6. I'm putting that whole thing here in, and I get 54.21. So that angle is 54.21. Once I have this angle and I have this angle, I can find theta. So theta plus x, which is 4.21, plus 18 equals 180 because it's a triangle. Therefore, theta is going to equal 180 minus 18 minus 54.21, which is this, or 107.79. Okay, I see my error. I am gonna have to go back. Okay, we've triangle PQR, and it says given PQR is obtuse, this angle here is obtuse, work out the area of the triangle. Okay, so guys, I don't have the height of the triangle, so I'm gonna have to use this formula. The formula is a half AB sine C. This formula is in the formula sheet. Now to use this, you need two sides and the angle between them. So I need this angle here. Let's call it X. But to get this angle, I could either use the cosine rule, which I can't because I don't have this side, or the sine rule, which I also can't use because I don't have this side. But I can use the sine rule, and he does kind of mention PQR as an obtuse here, so he's obtuse. So I can use the sine rule with this angle. Let's call this angle theta. I'll use the sine rule with this angle, and then I can just subtract these two from 180 to get me X, and then I can use that rule. Okay, so let's find theta using the sine rule. So I'm going to say sine of theta over 4.2, sine of this over this, equals sine of this over 1.6, sine 18 over 1.6. Remember, if you want to find an angle, start with the angle up here. If you want to find a side, start with the side up here. They're both valid. Anyway, sine theta is equal to, I'm going to multiply across, so it's 4.2 sine 18 over 1.6, and then theta is the inverse sine of this. So inverse sine, I do shift sine, fraction 4.2 times sine 18 all over 1.6. Close this bracket, and I get 54.21. 54.21. Okay, that means, okay, and actually, here's the thing, guys, and here's why this question is really difficult. Theta is 50, that is true. That is true, that the inverse sine of this is 54.21. So I've done everything right. But, and this is why they say this is obtuse. This is clearly not 54.21. It doesn't look like it's 54.21 because it's bigger than 90. Yes, the diagram is not drawn to scale, but he specifically says this angle is obtuse, which means this angle is greater than 90. So what we have to do is say theta is 54.21 or 180 minus 54.21. And 180 minus 54.21 is 125.79. 125.79. Now this is the angle because it's obtuse. Now why can I do that? Well, you can do it for a number of reasons. One of them is if you actually draw the sine curve, what happens is it goes up and then it goes down and then up, and this is 180. So the sine of 54, wherever it is, like here, is gonna be the same as the sine of 180 minus 54. So the sine of this is equal to the sine of this, and I'll show you, I'll prove it. If I do sine of 125.79, I get 0.81111, and if I do sine of 54.21, I get 0.8111165. So it's the same thing. The sine of this equals the sine of this. And because I know it's obtuse, I'm going to say, well, it's not this, it has to be this. So theta is, and I'm just going to put it here as well, it's 125.79. Okay, so that means x, because I'm still trying to find x plus 125.79 plus 18 equals 180, which means x is going to be 180 minus these two things. So I'll do 180 minus 125.79 minus 18, and that gives me 36.21. And now that I have x, I can do my area. My area equals a half this times sine of this, 4.2 times 1.6 times sine 36.21, and this gives me 0.5 times 4.2 times 1.6 times sine 36.21, 1.9849, 1.9849, three significant figures, therefore 1.98. That is the area, so that is in centimeters squared, 1.98. Okay, question 24. A particle P moves along a straight line that passes through a fixed point O. The displacement x is given by this. The direction of motion reverses when P is at the point A. The acceleration of P at the instant when P is at A is this. Find the value of A. Okay, this is quite a difficult question, to be honest, guys. But there's a few ways that we can all definitely pick up marks. So one of them is, if I have the displacement, which I do, it's this thing. Actually, let me just draw it, write it here. X equals 4t cubed minus 27t plus 8. If you have the displacement, now before I even go into the question, I can get the velocity. The velocity is equal to dx dt. It's the derivative of this. So we're going to differentiate. This is a kinematics question, guys. It is a calculus question. It's a differentiation question. So we're going to differentiate. 3 times 4 is 12. Subtract 1 from the power is 2. This 27t just becomes 27 because we multiply by 1, and then this becomes t to the 0, which is 1, so that's gone. And constants disappear because you're multiplying by 0. Anyway, the constants, just remember, disappear. So that's my velocity. And seeing as he mentions acceleration, I can get the acceleration. The acceleration is the derivative of v. It's dv dt because it's the change in velocity with respect to time, the rate of change of velocity. So again, multiply by 2, 24t, and the 27 disappears just like the 8 did. Okay, so now guys, that's probably worth at least 2 marks. Well, probably 2 marks, what I've done so far. Then he says, the direction of motion of P reverses when P is at the point A on the line, right? So when does a particle in motion reverse? He reverses when the velocity changes from negative to positive or positive to negative. So watch this. If we're going this way, our velocity is negative. Let's just say it's a negative v. If we're going this way, it's a positive v. So if he changes from this way to this way, reverses direction, it's when the velocity changes. So I'm actually going to write that down. The direction of motion reverses. That's just a kind of fancy way of saying changes direction. Changes direction when velocity changes from positive to negative, or negative to positive. Now we're not sure yet which one it's going to be, but we're going to find out. Okay, so this is the velocity. This is the velocity function. Now guys, it will help you understand if you can graph this, and I'm actually going to graph this velocity function here. So this is t and this is v. How do we graph v? Equals 12t squared minus 27. So when I say graph it, I mean just a rough sketch. Now you could actually use your calculator, but I know the y-intercept or v-intercept is going to be negative 27 because it's just this when t is 0. So this is negative 27. And I can find my t-intercept, my x-intercepts, by solving this equation where 12 t squared minus 27 equals 0. Now guys, I'm aware this is a difficult question. So let's solve this. 12 t squared, I'm going to add 27 to this side. I'm going to divide by 12, 27 over 12, and then I'm going to get the square root of this. So the square root of 27 over 12, oh, it's actually 3.2, sorry, 3 over 2, which is 1.5, exactly. So it's 1.5 plus or minus 1.5. Okay, now, different scales obviously, guys. So this is 1.5, and if I was to draw it over here, this would be, sorry, 1.5. If I was to draw it over here, this would be negative 1.5. Okay, now I'm going to draw it like this first. Let's just go. Okay, thank you. Move that here. But something to note. This is only for when t is greater or equal to 0. So I'm actually not concerned with what's going on over here because nothing happened before 0. So all that's happening is this bit here. So my question was, when did the particle change direction? Well, it started off going negative. I was right actually to start with the negative. It started off going negative, and then after 1.5 seconds, it started going positive. That is because its velocity is negative here. That's a negative velocity because it's underneath. It's in the v is negative up until here, then the v is 0, and then it's going positive. So you can think of it like a car reversing, and then it stops and goes forward. That's what's happening. Okay, so when does it change direction? When t is 1.5. So therefore, I'll just write it here, changes direction when t equals 1.5, not negative 1.5, 1.5. But the final question says, or the question says, find the value of a. A is the acceleration at this time, essentially. Find the acceleration when p is at a, and p is at a at this time, because it is a is that time when he changes direction. Right, so I'm well aware, guys, that's obviously confusing, but I'm now just going to sub t into a. So a is equal to 24t at t equals 1.5, at t equals 1.5, a is equal to 24 times 1.5, and 24 times 1.5, you can use your calculator, guys, but it's 36. So a is 36, and you don't have to put meters per second squared because it's a meters per second squared. Okay, difficult question, guys, but anyway, here we go. This is question 25. Okay, we have a function, and it says this is only for x is greater or equal to 3, and we have to find the inverse function. Okay, so this is how we do these. We say let y equal 5 plus 6x minus x squared. and then we need to rearrange this to get, or sorry, first we swap the x and y. So swap x and y. We always swap x and y because that's what the inverse function is, essentially. So x is equal to 5 plus 6y minus y squared. Now the goal is to make y the subject of the formula. To do that, we have to complete the square. That's the only way to do it. So to complete the square, my way of doing it, guys, my kind of quick way to do it on the calculator is you put in your equation, polynomial, degree 2, put in -1, just be careful because it's -1 x squared, or y squared in this case, plus 6 and plus 5, and we get that and that, which I don't care about, but the max is 314. So the max is at 314. Okay, so I can then say x is equal to minus, because this is -1, that stays the same. I do y minus 3 from this 3 here, squared plus 14. And that's it. Now there's other ways to complete the square, guys, but if you multiply this out, you will see you get that. Okay, so this is x, but we're going to rearrange to get y. So first I'm going to subtract the 14, so x minus 14 equals minus y squared, sorry, minus y minus 3 squared. Then I'm going to divide by negative here, so this is actually going to become 14 minus x equals y minus 3 squared. Then I'm going to square root it. Y minus 3 is equal to the square root of 14 minus x. And then I'm going to add 3, so I'll just swap it over here, guys. It's going to be 3 plus this. So it's 3 plus, and it's plus or minus the square root of 14 minus x. Now this is the bit that's always very difficult to get right. The domain of the domain of the function is x is bigger or equal to 3. That means the domain of this is y is bigger or equal to 3. So y has to be bigger than or equal to 3, which means this has to be 3 plus this. It can't be 3 minus this. So I'm going to say, therefore, well, I'll say y or g minus 1 of x is greater or equal to 3. Therefore, g minus 1 of x equals, let's just bring this down here. Therefore, g minus 1 of x is equal to 3 plus the square root of 14 minus x. Okay, 3 plus the square root of 14 minus x. Okay, and then finally it says state the domain of g minus 1 of x. Okay, well, we cannot put into x anything that will make this square root, or we can't put into the function anything that will make this square root negative. So if I put in 3, that would be fine because I would have root 11. If I put in 6, this would be fine because I'd have root 8. If I put in 14, it would be fine because I would have root 0. But if I put in 15, if I put 15 in for x, I'm going to get square root of 14 minus 15, which is root minus 1, which I can't have because that's the square root of a negative number. I can't put in any number that includes 14.0001. I can't put that in because I'm going to get the square root of a negative number. So x has to be less than or equal to 14. Okay, that is the second last question, guys. Question 26. An arithmetic series has first term A, common difference D, where D is a prime number. So the common difference is a prime number. The sum of the first n terms is this, S of m is this, S of 2m is this. Find the value of D and the value of m. Okay, so guys, this is actually a really, really hard question. And in fact, I would imagine not many students got it. And I almost think it's an unfair question. But I'll let you decide that in a second. So we have the sum of n terms of a arithmetic series in the formula sheet at the start. It's this. It's n over 2, 2a plus m minus 1 d. So I'm going to use that. And I'm going to use it for this and for this. So s of m is going to be this with an m in it. Fine. So it's this with an m over 2, 2a plus m minus 1 d, and this is equal to 39. Okay, and my second equation will be, and actually guys, I'll just put this here. In fact, I'll delete that. This is just when I have an m in it, and then if I have a 2m, s of 2m, that's just going to be 2m over 2 brackets 2a plus 2m minus 1 times d, and this is equal to 320. Okay, so now I have two equations, but my problem is I have three unknowns, and this is why I say it's like a really difficult question. They've given me 2 bits of information, so I've made 2 equations. Fine, but I've an m, an a, and a d. So really, I need a third equation, which I can't get. I cannot make a third equation. The only thing I can use is this thing. It says d is a prime number. So we're going to use that at some point in this equation, or in this solution. So what I'll do is, and because he's only asked me to find d and m, that gives me the idea, let's say, to remove or eliminate to eliminate a. So I don't need a. I don't care about a. So let's simplify this equation first, and then we'll simplify this equation. First thing to do, guys, is I can multiply by 2 across here, because this 2 is outside this big bracket, so I can just multiply that 39 by 2. So this is 2a plus m minus 1d equals 39 times 2 is 78. I'm going to multiply this out. I get 2am plus 2am plus, just be careful here, this is m times d, which is m squared d. And guys, okay, why don't I put in an extra step, because this question is confusing enough. So it's 2a plus md, m times d is md, minus 1 times d is minus d, equals 78. And then I'm going to multiply this out. So this gives me my 2am plus m squared d, m squared this times this, plus or minus md, this m times this minus d, and this equals 78. Okay, then similar thing here, these 2's nicely cancel. Now I'm going to multiply out m times this is also, well, sorry guys, let's do the same thing. It's m 2a plus, I'll multiply this out, 2md minus d, 2md minus d equals 320. Now multiply this, 2am plus 2m squared d minus md equals 320. Okay, now I have, and this is why I could just about see how we could be expected to figure out this question. The 2am and the md, both equations have a 2am and a minus md. 2am and a minus md. So what I'll do is I'll subtract the equations. So I'm going to put this 3. No, I'm going to put this one first. There's 2am plus 2m squared d minus md equals 320. And here 2am plus m squared d minus md, minus md equals 78. I'm going to put a line underneath, and because the ones I want to eliminate, these two have the same sign, I'm going to subtract. So this minus this is 0, these disappear. This minus this is just m squared d, and this minus this is 0. So these two terms, well, 4 terms if you like, disappear, and I'm left with m squared d is equal to 320 minus 78. Let's just make sure I know how to do that, guys. 320 minus 78 is 242. Okay, 242. So now I have the two things that I want, my m and my d, and I have one equation. Now this is why I say it's almost, I'm not going to say it's an unfair question, but it's close to an unfair question, because I have two unknowns and one equation, and I need to solve it. Now the only thing I can use is the fact that d is a prime number. So I have to just kind of try different prime numbers and see what happens. Now they have been kind to us, and actually the answer is the very first prime number. So I need to consider different prime numbers. Consider prime numbers for prime numbers for d. Now what happens is, if d is equal to 2, m squared, this is the first prime number, by the way, guys, 2. So if d is 2, m squared is 242 divided by 2, which is 121. And that is a square number, so I can get m is equal to 11, because m has to be a whole number, because it's the mth term. It's like the first term, second. This is like the sum of the first m terms, the sum of the first 11 terms. So it wouldn't make sense if m wasn't a whole number. So m has to be a whole number. So this is the answer. D is 2 and m is 11. So they've been nice to us and given us the first prime number. But if you wanted to check, so if you actually checked it, 242, if you divided it by 3, do you get a square number? And here, no, you don't even get a whole number. If you divide by 5, well, you definitely can't divide by 5. Divide by 7, no. Divide by 11, yes, we know it divides by 11, but 22 is not a square number, so that's no good. And again, you can go through them all. Divide by 19, divide by whatever, but you don't have to go through them all, because we found it from the first one. And I would wager there is no other prime number that you can multiply by a square number to get 242. So fair enough, it's a difficult question. It's the last question on the paper, but that's how you do it. Okay, that's it, guys. I'll see you in the next video.